Hello everyone, this is Team 5 from N Division. Firstly, we all are very grateful to work with the given need statement Decoratives under the guidance of Professor Kaushik, and also thankful for this wonderful course called Engineering Exploration. Now I would like to introduce the members of our team, Priyanka Megharaj, Ritu Reddy, Prapti Gowda and myself Sukruti Joshi. So starting with our problem definition of our project, that is decorative coffee table. Problem definition mainly consists of objectives, functions and constraints. So here we have differentiated these three with different colors, that is objective with red, functions with yellow and constraints with blue. So here is our problem definition. Designing and portable decorative coffee table that is of maximum durability, low maintenance and attractive decorative item. This decorative item has more brightness with colorful light effects. It is featured with an adjustable background light color. It is supported with sensor so that it senses wherever the object is placed and turns light on. This beautiful decorative table is entertaining and user-friendly with less power consumption. The table dimensions of 8 mm thickness and 8 cm wide per block. Height of the table about 20 cm and length between 30 to 40 cm. It should be completed within 4 months time while not costing more than 4,000. Next, coming to function tree and functional clustering. So, function tree mainly consists of 4 main functions with its 4 different sub-functions. So, the main functions are sensing, changing color, user interface and casing. Sub-functions under sensing are placing objects, music beats, touch sensing. Sub-functions under changing color, background color adjustment, varying brightness, Bluetooth setting. Sub-functions under user interface, that is display and user input. Lastly, coming to casing, its sub-functions are assembling and cutting. So in functional clustering, we have clustered the sub-functions under different main functions. So next, coming to the functional specification of the entire system. First one, varying brightness. Its specification is control the brightness via mobile through Bluetooth module. Second one is the changing the color. Its specification is the table should be of common color and change color wherever the object is placed. Third one is background color adjustment, and its specification is change the background color through application with Bluetooth module. And lastly, the sensing, and its specification is placing sensor in each block.
Next, moving towards the subsystems identified in our project. Totally, there are 3 subsystems. Subsystem 1, user input unit. Subsystem 2, light unit. Subsystem 3, sensing unit. So, coming towards the interface performance specifications. Here we get to know about the interface between each subsystem and its specification. So I would like to explain one example. So firstly, we divide 2 units, that is user input unit and other one is the function in our project, can be considered as one unit, like one we have taken light unit. So material interaction and data interaction requires the light unit and it is not required for spatial interaction. Next is the generated concepts. Totally there are 4 concepts and LED is common in all four concepts. So coming towards the first concept, its speciality is, as we can see, the table is equally divided. Half of the table is considered into study table consisting of study lamp. In our second concept, the table is facilitated with speaker. The speciality of third concept is supported with portable USB, and the last concept is completely filled with LEDs. Next, coming to the pug chart. In pug chart, we have selected 5 objectives and given particular weightage so that we can select the best among the 4 concepts. So as you all can see this pug chart, we have selected concept fourth as datum. So according to that, we have given rating to the other concepts. Finally, we totaled all the ratings separately of a particular concept.
Step 3 was virtual implementation, in which we were asked to make 3D model of the entire system, circuit diagram, flowchart of the entire system, bill of materials of the system, motor sizing and battery sizing of the system. Firstly, the 3D model of the entire system. To create the 3D model, we used the software that is Autodesk Inventor. This is the 3D model we created. This whole is a table with top and bottom 4 legs. This is the top with blocks, that is 25 blocks. We use the software that is Autodesk Inventor. This is the 3D model we created. This whole is a table with top and bottom 4 legs. This is the circuit board placed under the blocks. Below this is the vacant space where power supply is placed. And this is a bottom leg where are 4 legs. Next, the circuit diagram consists of Arduino Mega 2560, 25 LEDs and 25 sensors, extended power supply and Bluetooth module. Next is the flowchart of the entire system, and here it goes. Start. When you start, if the battery is on, the table is set to be common color background. Next, if an object is sensed by any of the sensors of a block, then that block LED color is changed. Then if the battery is off, then stop.
Next is the bill of materials required for the entire system. In this table, we have part name, material with which the part is made of, specification of part, quantity required. In our model, we totally observed 11 parts and their quantities required. Next comes the motor sizing and battery sizing of the entire system. We aren't using any motors in our model, so motor sizing is not required. In our model, we are using addressable pixel strip of 30 LEDs per meter, and in which we need only 25 LEDs. By this, we calculated power consumed, that is equal to 7.47 watts. Voltage is 5 volts DC. Now, the model is supposed to be running for approximately 3 hours and assuming the efficiency of 85%. By this information, we calculated the watt hours, that is equal to 26.36 watt hours. Next, we calculated the ampere hour using the watt hour, that is equal to 5.272 ampere hour. So the proper battery to be used for our model, after looking through the specifications calculated, is 6 volts 7 ampere hour. Next is the simulation and modeling. So in our simulation, we used Arduino Uno, breadboard, LED strip, that is of 10 LEDs, a sensor which gets the input from the IR remote with values 0 to 9. So these values 0 to 9 is the input for those 10 LEDs respectively. When the simulation is start, this LED is set to a common color. Here it is red. So when the input is 0, LED 1 changes its color to blue. That is, the IR sensor of first LED is sensed and the color is changed. The same is for all the input values. That is the fifth LED. Next, here is the app which we need for a model. That is the app controller which receives input from the user connected through Bluetooth module. What input? So the input of what color should be the background and the varying of brightness. And this was our final presentation on our first engineering project. This was a great experience as it introduced us to the world of engineering. It acknowledged us about the mechatronics. Working in team spirit, and it was so good to work with the mentors who guided us with their knowledge and who really made this project so interesting. Last but not the least, our first engineering project was successful and we look forward to make such projects in our engineering course. Thank you.